Hi everyone, we are now going to continue with our lessons on quadratics. So far we've seen two forms of parabolas. The first one we saw was the standard form, which looks like this: y equals ax squared plus bx plus c. And this is the standard form. Alright, and what we learned from here was that this is the vertical stretch. I'm just going to write vs for vertical stretch. And C was the y-intercept. Y-intercept. Then what we did was we factored this, and we found another form of the for the parabola, which is y is equal to a x minus p x minus q. And what we learned from this one was that a, once again, and it's the exact same a, it's also the vertical stretch. P and q actually now stand for the x-intercepts. The x-intercepts. And what we've learned so far is to go from the standard form to, oh, let me just write that. This is the factored form. This is the factored form. What we've learned so far is to go from one form, in other words, the standard form, to the factored form. What we're going to learn today is to do the opposite. In other words, go from factored form to standard form. You pretty much already know how to do that, but we're just going to explore that anyways. Before we move on, I just want to clarify two concepts, which is how to find the y-intercept and the x-intercept. So let's just go down here. So if you want to find the y-intercept, and this applies for any function, it doesn't necessarily apply just for parabolas, this applies for any function. If you ever want to find the y-intercept, it's always when x equals 0. So for example, let me give you an example. Let's do y is equal to 2x minus 3 x plus 1. So if I want to find the y-intercept, all I have to do is set x equal to 0. So in this case, y is equal to 2, so x is going to be 0, so I'm just going to write that 0 minus 3, and then I'm going to put 0, and then it's going to be plus 1. So this is basically 2 times negative 3 times 1, so it's equal to negative 6. So my y-intercept is negative 6, and if I had to write this as a coordinate, it would be 0, negative 6, and that's the coordinate of the y-intercept. The next concept I want to go over is the x-intercept. So let's do that right here. So the x-intercept, and the x-intercept, so if the y-intercept, let's just go back here, if the y-intercept is x equals 0, right, the x-intercept is basically going to be where y equals 0. Okay, so it's very important to remember that. The x-intercept is y equals 0, and the y-intercept is x equals 0. So let me just do a quick example of this. We can do y equals x squared plus 5x plus 6. Now if I set y equals 0, you can do x squared plus 5x plus 6, and now the question is to solve for x. Now we haven't really learned how to solve for this when it's sort of in this standard form. So the best thing to do is to convert into factored form. So if you use the man method and do that, you will see that, okay, let me just do the man method here. So m is 1 times 6, so that's equal to 6. A is the middle term, which is 5. You need two numbers that multiply to 6 and add up to 5, so that's 2 and 3. So it becomes x squared plus 2x plus 3x plus 6. You group the first two, group the last two. So 0 equals x plus 2 plus 3 x plus 2. And then we get 0 is equal to x plus 3 times x plus 2. You can set each of these to 0. So x plus 3 equals 0. So x equals negative 3. And then x plus 2 equals 0. So x equals negative 2. And these are our x-intercepts. So the most important takeaway that I want you to have from this is that when we have the x-intercept, you set y to 0 and then you solve for x. And vice versa, if you want to find the y-intercept, you set x equal to 0 and then you solve for y. Alright, so I'll see you in the next video.